stretch happens when a function is multiplied by a factor greater than 1. So if you think about something stretching, you stretch it out, it gets bigger. So well, at least that's what we think of. That's what I think of when I think of stretching something. We make it bigger. So the way we do that is by multiplying it by something bigger than 1. So it could be 1.00001, and it'll still get bigger. Okay, if it's right at 1, it'll stay the same. But a vertical shrink happens when a function is multiplied by a factor greater than 0 and less than 1. Okay, so we've got, basically we have a fraction that's between 0 and 1. And that makes things shrink up if I multiply it by something between 0 and 1. So let's look at some examples. Okay, here we've got an absolute value function. It says graph the function and the parent function, describe what's happening. All right, so the parent function for an absolute value just looks like a regular line going that way and a regular line going that way. So there is the parent function. I know I keep changing colors. I've been doing the parent function in orange. Sorry about that. Okay, but now we want to see what happens to this when we multiply it by 2. Okay, this would be considered a stretch. This is when we're going to make it bigger. All right, so if I make a table, I have, let's see, -2, -1, 0, 1. These are just usually the ones that I use. Okay, the absolute value of -2 is 2, so 2 times 2 is 4. Absolute value of -1 is 1. 2 times 1 is 2. This is going to be 0, this will be 2, this will be 4. So I come over here and I have -2, 4. I have -1, 2. I have 0, 0, 1, 2, and 2, 4. So it comes along and does this. Now these used to confuse me when I was a kid because I'm like, that looks like it's shrinking. But if you think of it, you have to think about it in terms of the the x-axis. It is stretching away from the x-axis. Plus, when you multiply it by 2, it's just going to get bigger faster. So as they're closing up like this, it means that they're stretching. Okay, so now I would like you to try this one. This is a quadratic, but I'd like you to try this one, so pause right now. All right, so quadratic, again, my parent function is x squared. And we've done these before, 0, 0, 1, 1, 2, 4, and it looks the same on both sides. So here it is. But let's see what happens when I multiply it by a half. Remember, this is going to be a shrink. All right, so I'm going to make my table again. And because it's a 1/2, I'm going to pick x values that are even, just so it's easier to figure out, to do the calculation. So I'm going to do -4, -2, 0, 2, and 4. So -4 divided by 2, -4 squared is 16, divided by 2 is 8. -2 squared is 4, divided by 2 is 2. 0 squared is 0, times 1/2 is 0. 2 squared is 4, divided by 2. 4 squared is 16, divided by 2, which is 8. Okay, so I'm going to come over here. I've got -4, 8. 1, 2, 3, 4, 5, 6, 7, 8. I've got -2, 2, 0, 0. I'll have 2, 2, and 4, 8. So here is my new, oops, did I do that right? 1, 2, 3, 4, yeah. So here's my new parabola. Again, this one is actually shrinking. So we're comparing it to the x-axis. So as it goes down, it shrinking. I know that's weird. So like think of stretching like, oh, I'm stretching. And so you're getting bigger this way and shrinking. I don't know, maybe you're going, I'm shrinking, I'm shrinking. I don't know. Maybe something like that helps you. It helps me to think of dumb stuff like that. Okay, I hope you got that one. All right, lastly, we're just gonna do a story problem, and I will do that in the next video.